live!
Hi folks, and welcome to an OA Labs Patreon exclusive tutorial. So today what we're going to do is we're going to look at how to debug a DLL where the code you want to debug is in an export of the DLL and it's not in DLL main. Now the sample that we're going to be using today is the payload for Squirrel Waffle, and we've done a static analysis of Squirrel Waffle on our YouTube channel where we showed you guys how to statically analyze where the config is stored and build a config extractor for it. What we're going to do today is we're going to show you how to use x64dbg to extract the config dynamically in a debugger. And the technique that we're going to show today is not just specific to Squirrel Waffle. It can be used for any DLL where the code that you want to access is in an export, not in DLL main. Now before we get into this, the VM that I'm using here today is a Flare VM, and if you want to know how to install a free version of this so you can follow along at home, check out our Patreon post on building a dynamic malware lab. So if you follow that tutorial, you should have a VM set up exactly like this with the same tools that we have installed. And if you want to download the Squirrel Waffle DLL to play along at home, it's on Malshare, and there will be a link along with this video. So you can go and download it and follow along at home. Now, what am I talking about by having code in an export that you want to debug? Well, let me show you an IDA here. So we have a free version of IDA installed in our VM. Let's open this up. Yes, let's open Squirrel Waffle here. And if you've seen our YouTube video, in the exports here, see there's an export called loader and the ordinal is 1, and that's where the config decryption happens for this DLL. The DLL entry point, which is DLL main, doesn't have any interesting code in it for the purposes of this tutorial. So if we were to just try and load this DLL with the default loader for x64dbg, it wouldn't call this loader export, it would just call the DLL entry point, and we wouldn't be able to debug the code that's located in the loader export. So what I'm going to do is I'm going to show you guys how to load the DLL in x64dbg, break on the load, and then change the execution pointer to point to this ordinal so you can start debugging there. So let's hop over to x64dbg here and we'll see if we can't get this set up. So you'll notice that it's actually x32dbg, and that's just because this is a 32-bit DLL, and so we're using the 32-bit version of x64dbg. So let's open up our Squirrel Waffle DLL. And what's interesting here is when you open a DLL in x64dbg, of course, you can't just directly execute a DLL on Windows. It has to be loaded by another program and then execution passed to it. So what x64dbg does for us is they helpfully create a DLL loader PE file. They dynamically do this, and then they use that PE file to load the DLL. So this is actually a file, and if we look on our desktop here, you can see they've created that file. They've written a PE file there. And the purpose of this PE file is simply to load the DLL that we've dragged and dropped into x64dbg. Now, like I said before, if we were just to execute this file, nothing would happen. We wouldn't get the execution of the loader export that we want. We would just call the DLL main for the DLL, and then the DLL would exit. So what we want to do is we want to set up some options here so that we can break when that entry point is called for the DLL. So if we go to Options, Preferences, and then under Events, we check DLL entry. What this does is this sets a breakpoint on the entry point for any DLL that's loaded. So now, as soon as execution is passed to the entry point, to DLL main, there'll be a breakpoint set and x64dbg will stop. Then what we'll do is we'll run it until we hit that breakpoint. Then we will transfer execution to the export that we want to actually debug. So I'll show you how to do that now. We'll save this, execute. Now you might have noticed something. Execution failed. Nothing happened. This is something that happens, I'm not exactly sure why, but it happens a lot when you use the automated DLL loader for x64dbg. Now you can take a different path and you can use run DLL32. I'm not going to show you that in this tutorial because this loader is going to work just fine. All we need to do is run it a couple times until we get to our breakpoint. So I'm not sure, it might be some timing error or something like that, but it's not a big deal. We can just try it again. There we go. So we ran that a couple times, and now you can see there's a breakpoint on entry point in the Squirrel DLL. So that might have seemed a little bit out of control, but again, we're in a VM that's completely safe to execute malware in, so there's no harm in retrying it a couple of times. Again, I believe this is some sort of timing issue with the DLL loader, but I'm not exactly sure. It's not a big deal if this happens. You can just reload it a couple times until you hit that breakpoint. And again, you're looking for this pause notification, which means you've hit a breakpoint, and you're looking to see what kind of breakpoint is. You want to see an entry point breakpoint, and you want to see it on the DLL that you want to actually debug. So we can see now, if we want to double check what we have, we can look at our memory map, and we can see that the squirrel DLL has actually been loaded at this address here, 5, 8, and 4 zeros. So we can see the DLL is loaded. This black bar means that our execution is in the text section of the DLL. And of course, that's where the code is. So what we want to do now, if we go back to the CPU view, is we want to change our execution pointer, instruction pointer, and we want it to point at the export where the code is that we want to actually start debugging. So how do we find that code? There's two ways, and I'll show you both of them just in case one of them isn't available to you. The first way is the easiest. If we look at IDA here, you can see we're in the Exports tab. Here's the export that we want to debug, and you can see this is the address for it. So if we double click Show Text View, you can see this is the virtual address for that function, and so we could just change EIP to point to that virtual address. Now this might not always work because in some cases the DLL will not be loaded at the preferred base address. So the preferred base address for this DLL is 5, 8, and 4 zeros, and of course we saw in x64 debug that it was loaded at 5, 8, and 4 zeros. So we got the preferred base address, which means that automatically all the addresses in IDA will match up with the addresses in x64 debug. This isn't always the case, and if it's not the case, if you're seeing things aren't matching up, you can go to PEBear, load the DLL. Of course, in the optional header, you'll see the image base, 5, 8, and 4 zeros. That's the preferred image base. So if this doesn't match the virtual address where the DLL has been loaded in x64 debug, then you have an issue. And in that case, what you need to do is you need to go into PEBear, go to the exports, find the RVA of the function for the ordinal that you want to debug. And of course, the ordinal is just a numeric way of addressing exports. So you can see the export name loader is ordinal 1. So ordinal 1 in PEBear is the same as that loader export. It's just instead of using a name, they're using a number. So you have ordinal 1 is at RVA 5610. RVA stands for relative virtual address, and it is relative to the base address of the DLL. So all you need to do is add the RVA to the base address, and then you'll have the new address for that export. So 5610 plus the base address of the DLL, which is 5, 8, and 4 zeros. So what does that give us? 5, 8, 5610. And what is the actual address in IDA? 585610. Everything checks out. So now what we can do is we can go to our x64 debug, go to the CPU view, change EIP, right click, modify value, change it to 585610. Okay, so now our execution is going to start at this code here, and of course that code looks like what we have here. Same code. So now when we start executing, we'll start executing here instead of at DLL main. So that's all you need to do if you want to execute code that's in an export for a DLL that's not in DLL main. That's it. You just have to change the EIP once you break on the DLL entry point. That's it. What I'll do here for a little bonus is I'll show you how to get the config out of Squirrel Waffle. And to do that, you'll have to reference our YouTube video where we did this statically, because I'm going to go over the reverse engineering part of this very quickly. In that video, we showed that in this call here, we have a key and we have a piece of data in memory. And that key and piece of data in memory are passed to this function here, and this function is used to decrypt that data. So what we can do is we can find this function in x64 debug. So we'll just copy this virtual address because we know that these virtual addresses match up with the ones in x64 debug. So we can just copy that virtual address. We can go to x64 debug. we can click in the CPU view, press Control G, and then paste in that address. Click OK, place a breakpoint at that address, and now when that decryption function is called, we'll break, and then all we'll have to do is step over and we'll look at the return value in EAX, which is where the return is for that function. So let's run. We've hit that function. Let's step over, and now let's look at EAX in our memory. Right click, follow and dump. Of course, it's passed by reference, so that means that in the EAX register is the address where the actual config data is stored. So we highlight that address, right click, follow dword in current dump, and there we go. We can see these are all the block list IPs for the config. So that's it. That's all you have to do to decrypt this config dynamically, and that's the method that you would use if you want to call an export for DLL and execute the code in that in a debugger. Hope you enjoyed, and stay tuned for more. And remember, if you have any questions, reach out to us on Discord. Let us know what you're thinking, feedback. It's all welcome. Hope to see you there.